So good day to everyone. Today we're going to discuss all about capacitors. This will be our lesson number 5 and this will also be included in your midterm examination. So when we talk about capacitor, no, it is an essential element when it comes to electronic system. So let us first define capacitors. Capacitors is a component that has the ability to store electrical charges or voltages. Okay. Let's highlight that. No? It has the ability to store. Okay, to store electrical charges or voltages. It's all we can view it, or we can say na it is also like a battery. So later on, we will compare it side by side with batteries. First, muna beforehand, no, capacitors were called as condensers, okay? Pero as of the moment, no, in the industry standards, we are calling it as capacitors na. So let us move on. Capacitors versus batteries. Capacitors and batteries can both store energy, okay? But capacitors tend to store less energy, but it can charge much faster. Okay? While on the other hand, battery can store more energy, but it charges in a much lower state. Okay? So yun yung pinagkaiba ng battery and ng capacitor. Pareho sila nag-i-store ng energy, pero mas mabilis siyang ma-charge yung capacitor natin. Okay? Pero yung battery natin, mas marami ang energy na i-store niya, pero mas mabagal naman kasi siyang nag-charge. So, ang capacitors, they act like a storage container. Okay? So, if we have a storage here, for an example, we have a storage container. So, what happens when you have a storage here? What tends to happen is, nag-fill up yung storage natin ng water. No? But, no, it also releases water. Okay? It also releases water. So, what tends to happen, no? This can be viewed as your capacitor. So what happens is, when there is a flow of electricity, no, the capacitor tends to store energy. Then what happens, it regulates the energy. So kapag nakapatay ito, diba? Kapag nakapatay ang ang gripo natin, or ang battery natin, or ang power source natin, meron pa rin nakastore ng energy dito, and hindi pa rin matatapos yung flow, diba? Mag-flow pa rin yan. Hihintayin mo na maubos, tapos doon pa lang mauubos yung flow ng tubig natin dito. Yun yung nangyayari kapag nagkakaroon tayo ng power interruptions, no? Pero may capacitor tayo. So kapag nag-interrupt yung power, meron pa rin lalabas na power. Kasi meron nga nakastore sa capacitor natin. Meron tayong backup energy. Okay? Pwede rin namang ang kuryente natin ay paputol-putol, di ba? Bubukas, sasara. Yun yung mangyayari kapag natin, di ba? Bubukas, magsasara yung capacitor natin, ay yung power source natin, in this case yung gripo natin, no? So what does capacitor does is it smooths out, no? Kahit magbukas yan o magsara, biglang bubukas, biglang sasara yung gripo, pero meron na nakastore na energy dito. So, continuous pa rin yung flow ng water natin, di ba? As long as may laman pa yung capacitor, no? So it regulates, it smooths out, no, the power or the electrons na meron sa capacitor. Next one. The capacitor is made up of these elements, no? We have our anode and our cathode. Then we have a separator. Tapos we have our container. Then the terminals, okay? We can determine the terminals kung ano yung positive and negative. Usually, meron na siyang indicator. Mapapansin nyo tong light phase dito, or kapag black yung capacitor natin, mapapansin natin meron siyang gray tapos nakaturo. Yun yung negative terminal. Okay? So, the insulating materials that separates the anode and the cathode, okay, are what? This anode and cathode are both conductive materials, no? They are both two plates. It can be aluminum, no? Aluminum plates that are placed together, that, you know, that they are placed together but they are not touching together. Why? Because there's a separator that separates the two conducting materials, no? And for that, we have the insulating materials, which is a dielectric insulating material. In terms of a dielectric insulating material, the material such as ceramic or glass is a non-metallic substance having a specific high resistance, no? Another example of a dielectric insulating materials, we can say na we have Teflon, glass, ceramic, yan ang mga dielectric insulating materials. This material also, no, polarizes when in contact with electrical field, okay? So we have those dielectric insulating materials that separates the anode and the cathode from our first figure, di ba? Meron tayong anode and cathode, tapos yung separator natin, nag-separate doon usually is a dielectric insulating material. Okay? So now, ito yung sinabi ko sa inyo paano mag-determine ng positive and negative terminal. Usually, ganito yung itsura ng ating mga capacitors. So when capacitors, no, mapapansin nyo itong gray na area na to, makikita nyo may negative sign na agad, di ba? So obvious na ito yung negative. Then this part is the positive. Okay, yun yung sa loob ng, ayun yung pagdedetermine, okay? Now, when and where do we use capacitors? Ayan, ganda to. So, for our capacitors, no, mapapansin natin na meron ito yung mga engineering drawing or yung symbols natin sa schematic when it comes to capacitors. This was first discussed, I believe, no, when to our first lesson. Diba? Meron tayong first lesson when it comes to capacitor symbols. Ito yung naging example natin for our laboratory number 1. So, ito yung sa natin, yung sa ating engineering drawing. So, meron tayong capacitor chart dito. Meron tayong radial ceramic capacitor, a 3-terminal capacitor, a wired-ended electrolytic capacitor, a surface mount capacitor, a motor run capacitor, a solid chip tanta, surface mount ceramic capacitor, suppressor capacitor, meron tayong polyester capacitor, polyfrene capacitor, memory backup capacitor, trimmer capacitor, polystyrene capacitor, aluminum electrolytic capacitor, PCB mount electrolytic capacitor, no? Yan yung mga common examples of capacitor. As for the functions of when and where do we use capacitors, capacitors are typically seen, no, in electronic circuits. Electronic circuits that requires a regulation of between the flow of electricity or the electrons, di ba? Gaya nga na sinabi natin, if we go back kanina, di ba? It serves like a container, no, that smooths out the flow of electricity. Kasi baka merong mga outages or mga fluctuations regarding with our electricity, no, or our power sources. Alam naman natin sa Pilipinas, 'di ba, minsan meron tayong mga power outages and meron tayong mga fluctuations when it comes to our power source, no? For our last quiz pala, maraming hindi nakakuha, no? Sana lagi natin tatandaan na ang power source sa Pilipinas ay typically 220 volts. Tapos naman sa ibang bansa, 'di ba? Makikita natin na meron silang 110 volts. So, when we decode a capacitor, mapapansin natin yan, for most available capacitors right now, no, meron na sila agad na naka-indicate. So, nakasulat na dito yung voltage na kaya niyang i-store. Ito yung maximum voltage na kaya niyang i-store. And yung amount ng farads. Yung farads po natin, yun yung measurement ng capacitance, okay? So, that is the farads, or symbol po ng farads is F. And this symbol is for micro. Meron siyang U, pero meron siyang mahabang buntot. That is farads. So when we see a capacitor like this, we have 10 farads and the maximum voltage that it can store is 35 volts. Now for capacitance, when you apply, let us first define capacitance. So kagaya ng sinabi ko sa inyo, ito yung computation when it comes to our capacitor. So when we talk about capacitance, when you apply an electric current, which is the flow of electric charge across the terminals of a capacitor, the charges get stuck on the capacitor plates. This is because the insulating dielectric material won't allow them to pass. As a result, negative charges start to build upon one plate and push like the charge away on the other plate, giving it a positive charge. Diba? Kasi meron tayong flow dito, pero imbis na magsama sila, na may separation, nandito kasi yung dielectric material. Imbis na yung conductive plates is magdidikit, ang nangyayari is pinupush away niya yung electrical charge natin, no? Kaya ang nangyayari po nun is nagkakaroon tayo ng build up of energy sa loob ng ating capacitors. Okay? Buray muna natin to para makita nyo mabuti yung figure, no? Ayan. Medyo kaya maganda yung kaya maganda yung alam natin yung schematic symbols, kasi kung papansinin natin from our activity beforehand, no, makikita nyo na magkakaroon na tayo ng idea. Meron kang two conductive plates. Ayan. Pero they are not touching each other, no? Wala siyang connection. But instead, ang nasa gitna nito usually is a dielectric material. Okay? Yun yung nasa gitna ng capacitor natin. Next one. From capacitors, no, we can compute kung mas marami ang electrical field na napoproduce niya, no? When we call that. So, yung voltage natin, ito yung sa voltage ng battery natin. Ito yung sa power source natin. Tapos naman, meron tayong distance ng plates. So, we can measure distance of plate by meters. So, we can compute then our electrical field. In terms naman, no, it can also affect, what can also be affected? Yung size ng conductor plates natin, no? Ng conducting plates natin. Baka meron kasing factor din yon, kasama siya sa next computation natin, na kung saan kapag mas larger yung surface area ng ating conducting plates is much higher yung makukuha nating value when it comes to capacitance. Okay? Sa electrical field din yun. So, later on, for your experiment, I have developed, or I have come up with a simulation in which you can view capacitance and capacitors, and also you can see, no, what happens when the surface area of your plates become larger, it becomes smaller, or the distance become larger, or the distance is much lower. You can see these relationships, no? I've come up with a simulation. So before we go into that, no, let me first just say po na meron tayong midterm exam. Then iba ang midterm exam niya for lecture, and also meron tayong midterm exam for your laboratory. So I will be discussing that in the next with your class president, and hopefully, no, yung yung midterm exam for your laboratory will be by, hindi po siya by group, no, by individual. So mabilis lang yung magiging midterm nyo. Bigyan ko kayo ng heads up, ang midterm niyo is makikita ko doon kung tumutulong ba kayo talaga sa mga activity nyo, kasi yung mga activity nyo lang rin ulit yung pag-aaralan natin during your exam. So makikita ko doon if meron bang learning in your part. So siyempre dapat talaga marunong tayo when it comes to actual, not just in theory. So yun, I'll see you all in midterm. So next one, we have here, no, our computation when it comes to capacitance. So sa permittivity ng dielectric natin, makukuha natin usually ang permittivity with a constant values. So later on, you will see in our laboratory activity kung ano yung mga values ng ating permittivity. Meron tayong dong Teflon, ceramic, and also glass. So for the capacitance in farads, we can compute it by C is equal to the permittivity multiplied by the area of the plate, and also over the distance between the plate in meters. That is how we compute capacitance in farads, no? That is the primary computation when it comes to conductors, 'di ba? Capacitance, madali lang naman eh. Capacitance equals conductors. Tapos inductance equals inductors, 'di ba? Para dagay na rin ito. So, yan yung mga pag-aaralan natin after ng midterms. Yun yung pag-aaralan natin, yung inductors naman. Pero yung midterms nyo, no, will be from lesson 1, which is symbols, up to this lesson 5, which is capacitance or conductors. So, ito yung formula natin. And next one, you will have your laboratory activity. Your laboratory activity, it is a detailed activity, no? In which, may kita nyo doon, if you try to open up the assignment tab, makikita nyo doon, meron tayong simulation. Yung simulation na yun is nagagawa lang siya through the use of a browser. Madali lang siya pindutin. And I want you to try, to play around the simulation and see kung ano yung nangyayari kapag nilalakihan yung plate, nililitan yung plate. Try to use the voltmeter, try to use the ammeter, try to create your DC circuit. And for that, after you got around playing with those circuits, what you can do is you play around, then you screenshot, no? Gawin nyo yung activity, screenshot nyo, make sure na may pangalan, or pwede kayong maglagay ng watermark na maliit para makikita kung kayo talaga yung gumawa. Kasi baka mamaya isang screenshot lang yun, no? Madali lang siyang makita kung ginawa nyo ba yung activity. I believe naman kasi dahil online class, I will be leaving the activity for 1 week. So magiging submission natin if today is Monday for my electrical students, no, your deadline will be on Friday. While on the other hand, for my students in the mechatronics, no, our class is on Saturday, so your deadline will be next Saturday then, or next meeting na natin. So that will be on our laboratory activity. So sa laboratory activity natin, no, hindi nyo need gumastos, madali lang siya dahil meron tayong simulations. Makikita natin doon yung relationship between the first two computations na meron tayo, in which the electrical field, the voltage, and the distance of the plate. And also, no, makikita natin doon when it comes to the capacitance is equal to permittivity. Makikita nyo doon, meron doon dielectric materials. And also makikita nyo doon yung area of the plate and the distance between the plates. So makikita natin doon yung flow of electrons, in which, no, ma-review natin in a visual manner. So ito yung ito yung lesson natin, last lesson for our midterm exam. So I hope, no, you will study for our midterms. Our midterms will be after this online class, and I hope and pray, no, na you will study, no, because midterms are 35% of your grade, and magkaiba po ang grade ng laboratory and grade ng lecture, so they are not the same, no. So I hope hindi lang po tayo sa laboratory nag-effort, but as much possible is mag-effort din tayo sa lecture natin. So that's all for today. I hope you enjoyed our discussion, and I'll see you all on our midterm exam. Ciao!